Okay, now in mathematics we have rational numbers. Rational numbers can be represented as a fraction. Okay, it's the best way to represent them. Uh, so what happens if we're given an infinite repeating decimal and we say, okay, I don't want this infinite repeating decimal. I want its fraction form. Okay, so if somebody writes, you know, 0.7 bar, what they mean is 7, 7, 7, 7, 7, all the way off to infinity. Right? Well, I mean, even if you're using a computer and you try to use this number, eventually it's going to cut it off. Okay? It can't go off all the way to infinity. So if you want to take an infinite repeating decimal and you want to convert it into its fraction form, then what are you going to use? You're going to use geometric series. Okay, so another way to represent this problem is, well, 7 divided by 10 plus 7 divided by 100 plus 7 divided by 1,000 plus 7 divided by 1, 2, 3, 4, like that. Yep. Well, all of these have 7s on them. Okay, so cool, we can pull a 7 out. Okay, but we want to use the formula for geometric series. And the formula for geometric series, remember, it has to begin at n which equals 0. The first term has to be 1. So to get that first term to be 1, I'm going to pull a 1/10 out of everything. Like that. All right, now that would equal 7 divided by 10 times the sum n which equals 0 to infinity of 1 divided by 10 to the nth power, which would equal 7 divided by 10 times 1 divided by 1 minus 1 divided by 10, okay, which would equal, now this is 7 divided by 10. Now 1 minus 1/10 is 1 divided by 9 over 10, right? 10 and the 10 cancel each other out. And 7 divided by 9 is the fraction form of that infinite repeating decimal. Right now, this is just with a single number. What if we had a combination of numbers? Okay. Leave that up there for just a second. Okay, some of the people at home can catch up. But yeah, 0.77777 is really 7 divided by 9. All right. So let's say we had let's say 65 bar, which would equal 0.65656565, yada yada yada, off into infinity. Okay. So we have an infinite repeating decimal, but with just 2 digits instead of the other one had just 1. And so this would equal, right now, 65 divided by 100 plus, now 65 divided by 1, 2, 3, 4, and then plus 65 divided by 1, 2, 3, 4, 5, 6, like that, and then we go down part to infinity, all right? Okay, everybody's got a 65, so we can pull that up. Now it's 1 divided by 100, plus 1 divided by 1, 2, 3, 4, 1 divided by 1, 2, 3, 4, 5, 6. Okay? But we don't like this. We can't use the formula for geometric series because it's not beginning with 1. So, that becomes 65 divided by 100 times 1 plus 1 divided by 100 plus 1, 2, 3, 4, dot, 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 which equals 65 divided by 100 times the sum, n, which equals 0 to infinity of now 1 divided by 100 to the nth power. Okay. So that would be 65 divided by 100 times 1 divided by 1 minus 1 divided by 100. Okay. Which would equal 65 divided by 100, and 1 divided by, this would be 99 divided by 100. Okay, let's cancel out. And we get 65 divided by 99. So that's how to turn an repeating decimal into its fraction form.